Okay, this lesson, it's lesson 8.4. We're going to discuss a very important topic. Okay, extremely tricky topic. Okay, this is called as a bitwise operators. So we use bitwise operators to manipulate on the bits, irrespective of the data type. The data can be int, char, short, long, whatever it is. We can use these operators to manipulate these at the bit level. Okay, however, we can't use them on float and double. Okay, so let's start with bitwise operators. I've just listed down all the bitwise operators that C provides. Okay, so the first thing is the ampersand and binary and. So with a binary and, right, one, everything except 1 and 1 is 0. So 1 and 1 is 1, everything else is 0. Okay, and with binary or, 0 and 0 is 0. Okay, and everything else is 1. Okay, and we have the XOR operator. With the XOR operator, you get a binary 1 when both the operands are different. If the operands are the same, you get 0. Okay, and then you have a left shift operator, which left shifts the bit by 1. Okay, and that is equivalent to multiplying the number by 2. And you have a right shift operator, which right shifts the number by 1, every binary number by 1. Okay, and again the complementary is, for example, you have a binary number, the complementary will be, for every 0 it will be substituted by 1, and every 1 will be substituted by 0. Okay, what I'm going to show you now is actual bitwise operations in a program. Okay, so here I've written a very small program, just not writing it in front of you because just to save time. So I've initialized C1 to 5, that is 101 in bits. Okay, and C2 to 6, that's 110. Okay, in bits. I'm just going to show you what's going to happen with AND operation and NOR operation. See, I'm just going through step by step. I'm just going to demonstrate to you what very basic bitwise operations, and then I'm going to take you deep dive into what's possible. Okay, I just don't want to overwhelm you, so that's the reason I'm going step by step. Okay, so let's see what's going to happen with AND. See here, 1 and 1 is 1. Okay, and 0 and 1 is 0, and 0 1 is 0. So it will be 4, and is 4, and R, I'll tell you what will happen. So 1 and 1 is 1, 0 and 1 is 1, and 0 and 1 is 1. So you will get 7 in an R, and this one in a 4 in AND. So let me just execute the program and show you how it works. See, C1 and C2 is 4, and C1 or C2 is 7, right? Okay, we're done with AND and OR. We're going to look at XOR, left shift, and right shift now. Okay, what's going to happen XOR, as I had explained, right? See, 1 and 1 is going to be 0. 0 and 1 is going to be 1, and 1 and 0 is going to be 1. Okay, so if the bits are the same, it is going to result in 0. Okay, so sure enough, I've already executed. I'll just show you, right? This XOR, right? Oh, sorry, there's a bit of a mistake here. So this has to be XOR. Okay, so this XOR, right? I'm just going to execute it again and show you. So XOR is 3. That's what I'm showing here. That's okay. Now left shift and right shift. So what's going to happen with left shift and right shift, I'm going to show you now. See this. So C1 is this, okay, 0 1 0 1. Okay, you're going to left shift by 1. Okay, what I'm trying to tell you is now is actually easy. Look at it. Okay, you're just going to left shift everything by 1. From here to here, you're going to left shift 1 and add a 0 at the right. Add a 0 at the right and get rid of a 0. That's false off. So now this is what will happen when you left shift. Okay, so when you left shift right? So now this is 8 plus 2, so 10. From 5 to 10, it's like multiplying by 2. Okay, let me show you what will happen when right shift. So now C2 is 6. Okay, that is 0 0 0 0 and 0 1 1 0. Okay, you right shift by 1. Okay, so what's going to happen, I just show you, copy it and you paste it. Right shift, you shift all the bits by 1 towards your right side. Now this one will fall off, so you just delete it, and when you delete it you add one more 0. Okay, and you're done. So this is what will be the result. So this will be 3. You know, it's like dividing by 3, but if it's an odd number, it would be divided by 3 and getting rid of the decimal places. So let me just execute it and show you. Okay, it's already executed. So C1 left shift is 10 and C2 right shift is 3. Okay, uh, now let us look at the last operator, that's a not operator. Okay, not C1. What happens is all the zeros will be converted into 1, 1 will be converted to 0. Okay, so basically it's a bit tricky, that's why I chose it to do it at the last. Why is it a bit tricky? Let me tell you. Because see, for example, I am actually printing an unsigned int. So what happens is the C1 is just 8 bits, but an unsigned int is actually 4 bytes, that is 32 bits. So this one will be converted into 32 bits, and then a not will be done on that. I'll just show you the result, what it's going to be. Okay, as you see, it's going to be a huge number. I'll just show you with the help of a scientific calculator why it's such a huge number. Okay, so let's get back to binary here. Okay, and let me type 5. Okay, 101. Okay, and it's a D word, double word, that means it is 4 bytes. Okay, and now let me do a not. What will happen? 32 bytes, and in the if you look at the first 3 bits, right? First 3 bits, you're going to see that in at the places where there is 5, where there is 5 and then there had to be a 1 is a 0, and then there's a 0 where there had to be 1, and the rest of the places where there had to be 0 there is 1, and that's what the not does. And let me convert it back to decimal. Okay, as you see, these two numbers are exactly the same. Okay, so that's what a not does. Okay, in this program, let's do something more useful. Okay, in this program what we're going to do is we're going to declare C1 to be 0. Okay, and this it's a 8-bit byte, and we're going to print for every bit, let's get to be 0, to get to be 1. So we're going to set the nth bit to be 1 for all 8 bits. So we're going to set the 0th bit to be 1 and print it, and then only the second bit to be 1 and print it, and then the third bit to be 1, and so on till the 7th bit. This is the 7th bit, this is the 0th bit. Okay, so we need a loop. Okay, and let's put the nth bit to be 0, n equal to 0 and n less than 8. Okay, 8, or we'll declare a hash define bits. Okay, we're going to do that. We're going to declare that hash define bits 8. Okay, and bit for all the 8 bits we're going to do it, and n plus plus. How are we going to do it? We're going to printf in terms of an integer. Okay, see, I'll tell you, whenever you have to make any bit 1, it has to be an OR. You have to use OR most probably. Okay, so you OR with something. What do you OR it with? You OR it with 1. So when you want to OR it with 1, you have to have 1 in that position. Okay, so how do you do it? You have 1 and you left shift it with as many bit positions you want. So in this case it is n. Okay, so let me put brackets around it. So I think we are done. Okay, so let's just see how it works. Let's just define n so that we don't have errors, and we will run it. Okay, what is undeclared here? Okay, semicolon. Sure, you see 1, 2, 4, 8, 16, 32, 64. If you observe, it is nothing but 2 per 0, 2 per 1, 2 per 2, 2 per 3, something like that. Okay. So this is what a very simple program. In the next lesson, we're going to look at a bit more complicated programs.